Now let's discuss the last module of this 5th unit, air conditioning. So far we have discussed HVAC. What is HVAC? Heating, ventilation and air conditioning. And so far we have already gone through what is ventilation and what is heating. Now let's enter the third module of this HVAC combination, that is air conditioning. So what is this air conditioning? Air conditioning is the process of removing the heat and moisture from the interior of an occupied space to improve the comfort of occupants. In common terms, air conditioning refers to the systems which cool air. Air conditioners uses the principle called refrigeration to chill indoor air, taking advantage of the remarkable physical law. That is, when a liquid converts to a gas in a process called phase conversion, it absorbs heat. The simple principle is, whenever the liquid phase changes into gas, it absorbs heat. It is the basic principle on which the air conditioner works. Now let's see the analogy to understand the functioning of air conditioner. To understand an air conditioner, just imagine a big tank full of water. And this tank is open to atmosphere and it is getting water from multiple sources like rain is filling it up. And someone has opened up a tap on top of it, etc. and etc. There are multiple options for filling this tank. Now the task at hand is to maintain the water level of the tank. So the water starts coming into the tank from multiple sources, maybe from rain or from the tap which is there at the top or some other reasons. But we need to always maintain the water level inside the tank irrespective of the inflow of water. Then what we have to do? So for that purpose, we have installed a tap at the bottom of the tank. Whenever the water level exceeds, then we will on the bottom tap, automatically the water will be drained from this tank and the water level is maintained. So now let's connect the analogy to the actual problem. The room or space to be air conditioned is similar to the tank illustrated in the analogy. So the tank which is there in the analogy is similar to a room which is to be air conditioned. And the heat in the room is analogous to the water in the tank. And the heat which is there inside this room is analogous to the water filling the tank. The tank is getting water from multiple sources, from rain and from the tap which is open and some other reasons. Similarly, the room gets heat from external sources like heat from outside the room through the walls, hot air flowing in, sunlight coming in from the windows and doors, people in the room, appliances in the room, etc. There are multiple reasons for the heat generated inside a room. Now, just like we need to maintain the height of the water in the analogy, we need to maintain the temperature in a room, right? How we have controlled the height of the water inside the tank irrespective of the inflow, in the same way we need to control the temperature of the room irrespective of the heat generated inside it. So a tap which is used at the bottom of the tank to maintain the water level of this tank is analogous to the air conditioner. So irrespective of the heat which is generated in the room, we need to maintain the temperature inside a room constant. And for doing that, we require a device called air conditioner, and thereby the tap in the illustration is analogous to the air conditioner. So now let's understand. So what the tap will do? The tap will just remove the water. Similarly, the air conditioner will just remove the heat. So the air conditioner does not generate cooling. It just removes the heat from the room and throws it outside. It is just like a tap which is removing the excess water from the tank. The air conditioner will never create cooling. It will just remove the heat, and because of that we will get the cooling sensation. Now let's see the working of an air conditioner. So the air conditioner works on the principle called vapor compression cycle. So to understand this vapor compression cycle, let's see an analogy. In the figure, you can see water is spilled over the room surface. Now how this water have to be removed from the surface? What you are doing? You are taking a wipe and you are soaking the wipe in the water which is spilled over the room, and then you will take it outside and then you wriggle it so that the water will come outside. So what you are doing here, whenever water got spilled on the floor, you are just taking a wipe and you are soaking that wipe with the water which is there on the floor, and then you are taking that cloth to the outside and then you are wriggling it. So when you wriggle it, automatically the water which is absorbed by the wipe will get removed. This is the same principle which is applied in air conditioner through vapor compression cycle. Now, in vapor compression cycle, the heat is like spilled water in a room. The heat which is there inside a room is just like a spilled water in a room. So, the refrigerant which is used in this air conditioning system is analogous to a wipe which is used to soak the water from the floor. And then what happens? The refrigerant soaks the heat inside the room at evaporator. Like how the wipe soaks the water, in a similar grounds, the refrigerant which is used in the air conditioning system will soak the heat. And this happens at evaporator. That is the indoor unit. And once the wipe got soaked with the water which is spilled over the floor, now you need to take this wipe to outside and you need to wriggle it so that the water will be ejected to the outside environment. So similarly, the compressor wriggles the refrigerant outside the room to reject the heat at condenser. Like how the cloth or the wipe is wriggled to remove the water from the wipe, see in a similar way, the refrigerant is wriggled by the compressor so that the absorbed heat from the refrigerant will be rejected to outside at the condenser, and this will take place in the outdoor unit. Soaking takes place in a device called evaporator in the indoor unit, and wriggling takes place in a device called compressor in the outdoor unit. So this vapor compression cycle altogether consists of 4 different parts. The first one is a compressor, the second one is a condenser, third one is a expansion valve, and the fourth one is a evaporator. So the soaking takes place in the evaporator and wriggling takes place in the condenser. Now let's see the different parts of an air conditioner. A split air conditioner unit has 4 key parts. They are compressor, condenser, evaporator and expansion or throttle valve. The outdoor unit consists of 2 components, whereas the indoor unit consists of other 2 components. So the indoor unit consists of expansion valve and evaporator where soaking takes place. The outdoor unit consists of compressor and condenser where wriggling takes place. So you have an air conditioner consisting of indoor unit and outdoor unit. Indoor unit consists of an expansion valve, evaporator and fan. Outdoor unit ODU also consists of a compressor, condenser and a fan. And you have a black color pipe called drain pipe through which water will be coming out from the split AC. And you have the red color one which is a electrical winding, and you have the blue color one whites which is the refrigerant lines. Now let's discuss the working of this air conditioner in detail. So the working of an air conditioner and how this air conditioner works. An air conditioner requires a chemical known as a refrigerant. Usually this refrigerant may be either freon or ammonia or any other type that can be easily gets converted from liquid to gas and back again. So the major important property of a refrigerant is conversion of that refrigerant liquid into gas and gas into liquid has to take place simultaneously with ease. So we need to choose such kind of refrigerant. Examples are freon or ammonia, right? So the refrigerant absorbs the heat from the air inside the building and then releases it outside. As I told you, refrigerant is similar to a wipe. How the wipe will absorb the water and bring it to the outside. Similarly, the refrigerant also will absorb the heat inside the room and take it to outside. And thereby the room gets cooled. As you can see in this figure, this air conditioner system consists of 4 different parts. You can see it here: compressor, condenser, expansion valve and evaporator. And we already seen that compressor and condenser forms the outdoor unit which is there at the outside of the room, and expansion valve and evaporator forms the indoor unit and which will be there inside the room. Now let's see the operation of this AC or an air conditioner. Now let's start the actual working. So in ACs we will use a refrigerant, and that refrigerant maybe either ammonia or freon. And these two, whatever may be the refrigerant which is used in the air conditioner, that should be initially in a vapor state or in a gaseous state. Right. Now, low pressure and low temperature refrigerant is taken in a compressor initially. And then the compressor compresses this low pressure and low temperature refrigerant gas or vapor and increases its pressure and temperature before sending it to the condenser. And what is the purpose of this compressor in the air conditioning unit? It will just compress the refrigerant vapor which is there at low pressure and low temperature. And because of this compression, the refrigerant vapor will turn into a high pressure and high temperature vapor. Then the high temperature and high pressure refrigerant vapor reaches the condenser and gets condensed into high pressure and high temperature liquid. Now, what is the purpose of a condenser? The condenser is a device where condensation will take place. What is condensation? Condensation is nothing but conversion of gas into liquid, and that will take place in the condenser here. At that high pressure and high temperature vapor, which is the output of the compressor, is sent as an input into the condenser, and in the condenser condensation will takes place and converts this high pressure and high temperature vapor into a high temperature and high pressure liquid. Right? As I already told you, when the liquid gets converted into gas or a gas gets converted into liquid, a huge amount of heat will be liberated. So during the process, lot of heat is generated in the condenser, and the fan in the condenser unit rejects the heat to outside environment. Understand this, right? So lot of heat is generated in the condenser whenever the high pressure high temperature vapor is converted into high pressure high temperature liquid, and these huge quantities of heat will be rejected to the environment by means of a fan which is used inside a condenser. So the outdoor unit consists of three parts: compressor, condenser and fan. The purpose of a compressor is to compress the low pressure and low temperature refrigerant vapor into a high pressure high temperature refrigerant vapor, and the purpose of a condenser is to convert this high pressure and high temperature refrigerant vapor into high pressure and high temperature refrigerant liquid. So in this process, huge amounts of heat will be generated, and that heat will be rejected to the outside environment by means of a fan which is used in the outdoor unit. And now this high pressure and high temperature refrigerant liquid will now enter into the indoor unit, and this indoor unit consists of expansion valve, evaporator and fan as well, right? And now what happens? Now this high pressure and high temperature refrigerant liquid will enter the expansion valve in the indoor unit. So what is an expansion valve? The expansion is opposite to that of a compression. So what happens in a compressor? Low pressure and low temperature will be converted into high pressure and high temperature. The exactly opposite will take place in the expansion valve. That is, this high pressure and high temperature refrigerant liquid will now again pass it through this expansion valve. So the high pressure and high temperature refrigerant liquid exiting the condenser is then pushed through the expansion valve, where the pressure drops and thereby the temperature also drops. The temperature of the low pressure refrigerant liquid exiting the expansion valve is lower than that of the room temperature. So what is the temperature of this low pressure refrigerant liquid which is exiting the expansion valve? It depends upon the temperature which you set inside a room. For example, if you keep 22 degrees, that is nothing but the temperature of this liquid. If you kept 24 degrees, that is nothing but the temperature of this liquid. So whatever the temperature you will set, depending upon the temperature, the low pressure refrigerant temperature will changes and matches with that temperature which you have kept through a remote control, right? So the temperature of the low pressure refrigerant liquid exiting the expansion valve is lower than that of the room temperature. And now this low pressure and low temperature refrigerant liquid is passed through the evaporator coil. You understand that, right? Now this low temperature and low pressure refrigerant liquid is passed through the evaporator coil. And now what happens? So as this occurs, the heat is extracted from the surrounding hot air in the room by the low temperature refrigerant liquid as it passes through the evaporator coil and gets converted into low pressure refrigerant vapor. Now what is happening here? So the output of this expansion valve is a low pressure and low temperature refrigerant liquid, and this refrigerant liquid will be now passed through the evaporator which is there in the indoor unit as well. Now what happens? Whenever this passes through the indoor unit, there is a fan to the indoor unit. What happens? This water or this refrigerant liquid, which is at a very low temperature, will absorb the heat inside the room, right? And because of the absorption of this heat inside the room, that low pressure liquid gets evaporated into low pressure vapor, right? So the indoor fan in the evaporator expels the cool air into the room to be cooled. Now once this refrigerant liquid, which is coming from the expansion valve, absorbs the heat, then automatically cool air will be circulated by means of a fan in the evaporator into the room, thereby cooling the room to its required level. And by absorbing the heat, this low pressure refrigerant liquid gets converted into low pressure refrigerant gas. And again this low pressure refrigerant gas will be passed through the compressor. And again the compressor will compresses this gas and it converts into high pressure and high temperature refrigerant gas. And the next cycle repeats. And this is how the air conditioner works. So on a whole now, at a glance, now this inside the AC, we will use a low pressure and low temperature refrigerant gas. And this low pressure and low temperature refrigerant gas will be made to pass through the compressor. And the compressor converts it into a high pressure and high temperature refrigerant gas. And then it will transfer it to the condenser, where condensation takes place. That is, this high pressure and high temperature refrigerant gas will be getting converted into high pressure and high temperature refrigerant liquid. So in this process, lot of heat will be liberated. This heat will be taken away to the outside by means of a fan which is used in the outdoor unit, right? And then this high temperature and high pressure refrigerant liquid is made to pass through the expansion valve. So, and this expansion valve will convert this high pressure and high temperature refrigerant liquid into a low pressure and low temperature refrigerant liquid. And again, this will be sent into the evaporator, and where the heat which is there inside the room will be absorbed by this low pressure and low temperature refrigerant liquid. And because of the heat absorption, this low pressure and low temperature refrigerant liquid converts into low pressure and low temperature refrigerant vapor, and again will be fed back to the compressor for next cycle. And because of this, because the heat got absorbed by the low pressure and low temperature refrigerant liquid, cool air will be circulated into the room and you will get the cooling effect. It is how the air conditioner system works. Now let's see an important point in a refrigeration system called cooling load. So what is a cooling load? So cooling load is the amount of heat energy that would need to be removed from a space to maintain the temperature in acceptable range. So the cooling load takes into account the room's construction and insulation, including floors, walls, ceilings and roof, as well as the room's glazing and skylights, based on the size, performance, shading and overshading. Therefore, a cooling load is the amount of heat energy that have to be removed from a space to maintain the temperature in a acceptable range, right? So what are the energy conservation measures in HVAC systems? The first step in energy saving on an HVAC system is to reduce the cooling load. The amount of electricity that the air conditioner system use depends on the cooling load. That is the amount of heat that has to be removed from the room. If the amount of heat that has to be removed from the room, or otherwise called cooling load, is more, then the power consumption will be more. If the cooling load is less, then the power consumption will be less. Then automatically the main important point in the energy conservation measures of an HVAC system is reduction of cooling load. So there are several steps to reduce the cooling load. The first one is insulate the cool space. The second one is minimize the use of appliances and lighting. And then use of variable speed drives on HVAC fans and pumps. Now let's see this one by one. Insulate the cool space. So this involves implementing various measures such as ceiling insulation, window glazing, blinds and door sweeps. And all these things will contribute to creating a thermal efficient shell that can dramatically reduce the cooling load on HVAC systems, while ensuring that comfortable internal temperatures are maintained. So reduce warm air infiltration into the cool space by keeping windows and doors closed when HVAC systems are in use. So when we insulate the room by means of a ceiling insulation, window glazing and blinds etc., we could able to reduce the cooling load. As well as if I can close the doors and windows while HVAC system is in operation, will also reduce my cooling load. And next one is to minimize the use of appliances and lighting. That is, all lights emit heat as we already know it. So the lights and other all equipments that are not required at any particular time should be switched off to help to reduce the cooling load. So when you turn off the lights and other equipment which are there inside your room, if they are not in working, when the AC is on, will reduce the cooling load on this air conditioner. Replacing the standard motors with high energy efficient motors also will result in lower losses. As we already know that the high energy efficient motors will have low losses and thereby less heat will be emitted from them because of their low losses, and this will reduce the cooling load in the space to be cooled. The use of variable speed drives on HVAC fans and pumps. So investing in variable speed drives, in short VSDs, for motors to match the speed with the output demand results in lower energy usage. So this allows motor driven loads such as fans and pumps to operate in response to varying load requirements instead of simply operating in on or off mode. So instead of simply operating in on mode or off mode, they could be able to operate according to the load requirement. And this is how we could able to reduce the energy consumption. So all these are the different energy conservation measures in HVAC systems. Now let's conclude this unit number 5. And this unit number 5 we have gone through what is an HVAC. So what are HVAC? Heating, ventilation and air conditioning. So in this unit initially we have gone through ventilation. We have seen what is a ventilation, what are the different types of ventilations. And then we have gone through the heating. The second module of this HVAC is heating. In this, we have gone through the different modes of heat transfer, that is conduction, convection and radiation. Later, we have gone through water heating and space heating systems. In the water heating systems, we have gone through active water heating systems and passive water heating systems. And this passive water heating systems is otherwise called natural circulation systems or thermosiphon systems. And the second one is a forced circulation system or an active water heating system, right? And later we have gone through the space heating. In the space heating again we have gone through two types. Active space heating by means of pumps and passive space heating by means of thermal wall. And later we have gone through electrical heating systems. And the principle of this electrical heating is Joule heating, right? So the devices which works on this principle are immersion heater and geyser. We have discussed briefly about the immersion heater and geyser. And later we have entered into our third module, that is air conditioning. We have seen what is an air initially, and then we have understood the functioning of an air conditioner by means of an analogy. And later we learned that the working principle of this air conditioning is vapor compression cycle, and the operation of this vapor compression cycle we have analyzed by means of a hype analogy. Later we have gone through the working of air conditioning system. This air conditioning system consists of two important components, indoor unit and outdoor unit. So indoor unit consists of evaporator, expansion valve and fan, and outdoor unit consists of condenser, compressor and fan. And we have gone through the working of this air conditioning unit in detail. And later we have gone through different energy conservation measures in HVAC systems. So with this we have completed our unit 5 as well as the subject, that is energy audit, conservation and management. Thanks for your support. Thanks for listening to these videos. Thank you.